Okay, we can start my little presentation today. Thank you all for being here, and I apologize first that I am a little jet lagged because I just came from Hawaii. It was beautiful, and I arrived 2 days ago and trying to cope with the different time zones and everything, and so I sound a little bit sleepy. So feel free to ask me any questions, and during the presentation. This will take about 30-40 minutes, but I can take my time to explain the fundamental idea of this research. This paper was presented last week on Thursday at Higgs conference. It was in the track of digital and social media, but very interesting, the mini track was in the crowdsource and collective intelligence. So I have been influenced by the Dr. Malone's work about 10 years ago. Was not thinking about adapting his theory into my work, and it was through an opportunity communicating with the mini track chair. Then I got this idea, and everything works. So this paper was presented at Higgs conference, but also recently I got a wonderful news that it is in another context, that's more data analysis describing about the computational intelligence has been accepted by the computers in human behavior. So, this is wonderful. So it's actually a combined presentation of two different papers, but they are in the same one study. So as you can see that the theme of most of my research is on computer-mediated deception, but this one is on collective language action cues as stigmergic signals for computational intelligence. And I'd like to acknowledge my collaborator, Dr. Hancock from Stanford University Department of Communication, because of a research grant from NSF Eager, and we continue to have the support of ICORT to understand how we can have the contribution of the research outflow into the market. I still have the idea, but that's something into the future, maybe in my next 5 years. So I also got a planning grant and a small grant from Florida Center for Cybersecurity. So this was a little bit acknowledgement of the funders. And you all probably wonder what this stigmergy referred to, right? How many of you have heard about the word stigmergy? No? Okay, well, interesting. I have a little diagram illustrating here. Stigmergy basically is a mechanism illustrating how bees, such as the bees, they work together to build their own little honey house, and also refers to also ants, how they build their ant hills, and they have special mechanisms that has been observed in biology field. That they call this mechanism as stigmergy. So so I borrowed this concept to look at the collective intelligence in social forum, in social phenomenons. So collective intelligence, to my belief, can be observed in group-based interaction as well as pairwise interaction. So mostly we talked about big data research, right? We get very excited about, wow, there is the big data research about political opinions, about how people, we use social network analysis to look at their interactions online, and those are huge data. And we can also use SNA to analyze the healthcare or this big collaborative projects. But as I communicated with the mini-track chair, he also acknowledged the interpersonal pairwise interaction as part of this overall, because they do illustrate some stories about how human interact, how human behaviors evolved in this interaction. So it is also enabled by some sort of stigmatic signals. So there must be some signals exchanged between humans in their interpersonal or group-based communication. So, so my base theory is that human sensors, they collaborate. There's some kind of innate ability that they can sense, coordinate, and solve problems through stigmatic signals. And this is not only my words, it's actually proposed by Dr. Malone, who is the director for the Center of Collective Intelligence at MIT. Before the collective intelligence, that he had this wonderful theories. He worked with Dr. Kevin Croston from Syracuse University, that he has been working to develop with Dr. Malone on the coordination theory. That is a very complicated theory, but they use the theory to analyze the large-scale collaboration projects. So they basically said there is some kind of signal, and that can enable the coordination or solving problems in the large scale, in the groups. In this research, specifically, I'm looking at the signals that has been exchanged between the human actors. So the efficacy of computational intelligence, how, if humans can sense, can we borrow that signal and computationally calculate, right? And what is the efficacy? What is the accuracy of using those signals to calculate the results that we want to see? So by adopting the collective language action cues of human intelligence, perhaps we can differentiate some kind of research problems. And that has been the overall theme of my research, and that is the computer-mediated deception in this world. So the problem, as I proposed to the mini-track chair, that in the social media areas, there are the threat agents and truth teller. Basically, it's in the pairwise interaction. So you have someone who tells the truth and someone deceives and try to exploit the informations from the truth tellers in the pairwise interaction. So in their interactions, they are sending signals. And so there can be significant problems such we often see as spear phishing, social engineering conversations, and also maybe some interactions, human-computer interactions with the fake websites. And all these are out there, and yet we have very little to do, to solve the problems. So unfortunately, the threat agents take advantage of the vulnerabilities of the truth tellers through this exploitation of the social engineering skills. So this manipulation of the naive users, they manipulate the naive users so they can gain more information in a way that's, through feeding the false belief, false perceptions in this conversation. So what kind of signals is the threat agent, is the deceiver sending in this communication? So as we all know that doing our research, we really need to focus on a specific research questions. And that's just, I think it helps me to focus what is the central problem of this research that I'm looking at, because there are so many problems that we can solve and so many approaches that we can adapt to address the problem. So basically with Dr. Hancock, we did ask ourselves a question: is it computationally feasible or viable to identify deception using some sort of language action cues as stigmergic signals in pairwise interaction? If so, how? So here I'd like to give you guys a little of the background. We propose a collective language action cues, but there are a lot of research established already in psychology, social psychology, and also some research established in information systems that they talk about the cues already. But I think several years ago, I was here making my presentation, and I did talk about some cues, but the way I look at the cues are, comparing the truth teller and deceiver, and whether how much truth teller tend to speak. Like, for example, the first person reference, did the truth teller speak more self-reference, or did the deceiver use more self-reference? So I compare single cues as the research outcome. So, but then you constantly compare your individual research with the research of social psychology, information systems, and many other researchers' work. And sometimes they contradict. It depends on how you interpret your research environment, and the experiment or different settings may influence the research outcome. So there must be something more than just the individual language action cues. So we explore this, and step by step, everything computationally. So here is just one slide to give you a little bit overview of the collective intelligence literature. Basically, it is a recent, about recent 1 decade, that's Halligan. He proposed that there is complex behavior between individuals, that they follow basic rules, just like ants, how they collaborate, just like how bees, they work together, So they don't need complex teaching, right? They don't need to tell you what you should do next, but they just work together, right? So they follow some basic rules. It's generally defined that the ability of a group to solve the problem more than individual members. So Dr. Malone basically said that stigmergic signal is part of the human's innate ability, the genes. So he has a paper in 2010 talking about genome, how this innate ability that really enabled humans to collaborate, to solve problems together. So for example, there is a hard problem, but through communication, I might be able to solve the problem with Marsha, through that communication. And in a large group too. One significant example is the open source collaboration. We see that there are wonderful products from Linux environments, the Linux operating systems. And there are many, in the technology world, there are many open source projects that have been developed through the collaboration of just, couple of people. They sign into the forum, they discuss with each other, then boom, have a wonderful product, and they enhance it, they make it open source, and so all the developers, they can contribute their intelligence ideas in this project. So, but I think the Uli, he's also a researcher that published at the same year to talk more specifically about the intelligence, collective intelligence factor. What are those factors? We think that there is a genome in the humans, but what are the factors that enable them to solve problems collectively, to coordinate on certain things? So he called this collective intelligence as the C factor. And very importantly, the C factors is not what we think as the average of the people in the room. It is not the average. It is not the average individual intelligence. So we think that we can come up with the C factor by averaging everybody in the room, your intelligence, find some ways to average them, and that's the C factor. He said, no. And it is more on the average of social sensitivity. So there is a sensitivity in each member that they exchange. They're able to sense in the group and the way the group member interacts when they are assembled. So we can see that the scientists, they assemble together in the room. They come up with different behavior, different product. But if today we find artists, they assemble together, they have different behavior, they have different product. So, and their social sensitivity is defined differently. And that is what is very important to make the collective intelligence factors. So let's further move on to a recent article by the Dipple in his paper in looking at the general theory of stigmergy. So he boldly proposed that there is a theory. We're not just observing some kind of mechanism anymore, but there is a theory. He proposed the theory and with 3 components. And the 3 components are, there must be some kind of actor. I think in Gary's theory on the theory of information world, that the actor is very important, right? In any kind of theories, there will be an agent, whether it's ants, bees, or humans. There is the agent. So I did a little experiment that in looking at computer-mediated deception, who are the agents? There must be a good agent and a bad agent. We don't want to say the bad agents, maybe something of the negative agents, the agent that produce the negative outcomes. So there is the dyadic view in the agents. But also agent produce the signs. And the signs in the work, we call the signs, they are the collective language action cues. They're not just the individual cues. For example, we know about game the game phenomenon. So I did this research several times. Every time I make the presentation, I tend to be asked of one question. So what does the deceiver, the liar, use more often? And so what does the truth teller use more often? So then in the future, they will try to use different words and this and that. So, but the signs, they are not just the individual cues. So here we propose it is the collective cues that we can model. And the third component is the environment, what we call the context. So there are different contexts, different scenarios, like the scientists work together versus artists working together versus musicians work together. There are different scenarios, different contexts, and different conversational subjects. They talk different subjects. So those are what we call the environment as the third component. So in this research, we did a little experiment here at FSU, and I designed a little game. And thanks to the the founders, support, we designed a little game at iSensor Lab, basically trying to study how this everything works. So I like to give you a little of the background. This will be a little bit of my original idea, looking at what is deception. So basically, Buller and Burgoon, they are the social psychologists, and they are in Arizona. And I work with her group, and her group influenced a bunch of information systems scientists. In fact, this time there was a 1.5 day workshop at Higgs conference. They were all just talking about these type of research, adapting the interpersonal deception theory of Buller-Burgoon's theory proposed in 1996. So there are many different ways that they talked about. For example, the deception takes strategy, and they basically foster a false belief within the receivers. So they want to do certain kind of things to make the receivers believe something different. So, and deception can be on the fly or planned. Dr. Whitty, this work was published at JASIS, and I really like this work, and I encourage you all to see how she writes about this deception in a different areas. They are differentiated basically on whether it's spontaneous, or some deceptions can take some planning. And there are also different significance in the deception. For example, people can just put out a little white lies. Oh, you look like I came in. I might feel very sleepy. But then, people will send sweet thoughts and words and, say you're fine, there's no problem. Or the deceptions can be serious, which can cause significant impact. There are different communication modes that can be synchronous or asynchronous. We see that they can be, there are research that study the 911 calls. So you can study the 911 calls transcript, or you can study the social media by extracting data out. And those are kind of the asynchronous mode, but in a way that if you use the chat forum, that can be a spontaneous environment where the chances for the deceiver to put out some false belief is very short and compressed, almost instantly, spontaneously. So these are the different elements within the deception. So just to give you a little bit of the theoretical ground of this work, I don't mean to bore you to death with all the theories that the research is based on, but I have one comment, and that is if you work on your research, and I find it personally very beneficial if I always start by looking at what does other researchers do, and is there any theories that will help to guide the thinking? What is the general theory in this area? So, and I found out that there are lots of this kind of work. So Miller and Steve's work, they are pretty much similar to Buller-Burgoon's theory. So the next theory is that I think this is a management theory. Basically, it proposed, and also by DiPolo. DiPolo is a social psychologist, and they basically argue that the deceivers will avoid discomfortness, right? Associated with lying. So then they tend to separate themselves from the person. So they create a social distance. So it's a psychology, theory that talks about the purposely separating. So you can measure, if you are measuring the face-to-face context, you can look at how the physical distance, or you can find ways in the social distance to analyze just analyze the deceivers. There are many different ways how you designed your research. So basically, social distance theorists promote and support the idea that deceivers will create more social distance. Deft is also in the management school, and he said that basically the deceivers will choose medias that will provide more cues. Because why more cues? Because they can confiscate, change, and manipulate the perceptions in the receivers, obfuscate their lies by sending different conflicting cues. So media richness theorists thinking that the richer the media is, the easier it is for the media to be used as a channel for deception. So we can see many of the examples that, in social media, yes? Right, exactly. It's very easy. Becomes more and more of all this fake news, all this, different thing, because there is no way to check the ground truth. The ground truth is no way to find. So they can use more of the social cues to create distance and to manipulate the deceivers. Hancock, he basically said there are more other factors. For example, if the media is non-recordable, then hey, come on, that's very easy for deceivers to feel very comfortable to express the deceptions and the ideas. So, and also whether the settings of whether they're co-present or they're geographically in different space, they all influence the deception and the deception outcome. So those are the features that Hancock identified. So enough about the theoretical background. So that's come into, based on the research, we want to explore the computational intelligence using the collective language action cues to look at this possibility of identifying this phenomenon computationally. How can we do that? So we designed a pairwise interaction game. I think some of you may have already played the game on the Saint or Sinner, that game. I'm not so sure if, no, you didn't. So basically, the participants play the game. One is, it's a random assignment. So they sign in as with a pseudo identity. So they're signed in and in a synchronous communication environment, and we hosted the game on Google Plus Hangout, and the game sessions were recorded on the MySQL database. Just a little bit of the overview of how the game was designed. Each of the player as the agent now think back of the components of the theory as well. So the agent, the signals, and the environment. So we're just thinking the general theory of stigmergy and to apply that in our research. So with regards to the agents, agents receive the random assignments. They come into the game as being assigned either an initiator or a detector, instigator. So one is the speaker and one is the instigator. So you can think of the dyadic role in each of the player. And later on, they swap their role. So in a way that they have some base understanding of the players for a certain amount of time, for the duration of 30 to 50 minutes, depending on how many sessions they play. And each of the speaker or initiator also is assigned with an inner role. So there is an outer role and there is the inner role. Outer role is whether you take the chance to speak, right? Or to detect. Inner role is whether you are assigned as a truth teller, the saint, or assigned as a sinner, right? To always speak but the lie. So that game was actually a lot of fun. As I talked about it, many of the Higgs conference participants, they also identified that this game must be a lot of fun. So I think this has a potential that I hope to develop a real game that it can play online. Not multiplayer game that's very sophisticated games, but the game can be played anytime two players sign in to the environment. So it is possible. So, so basically this is the settings. So they play, the speakers establish the ground truth, and the detectors will probe questions to determine whether it's the speaker is a truth teller or a liar. So the concept is very easy. So I give you a scenario. For example, have you ever received a speeding ticket? And the ground truth is yes. The detector's question would attempt to learn whether the speaker has received a ticket by many different ways to probe. And the initiator, if it's a sinner, then will respond to obfuscate, to mislead the instigator in different direction because it's because of the inner role as the sinner. So in that, you can see how they play dynamically. So this is the a little bit of the screenshot to how the game was designed. Very simple. The outer role detector, inner role saint, their duty, what the things they should do, they shouldn't do, and have you do something scenarios, and then you do the answer. So here, this is a little bit of the video play just to show you that when they sign into the games, they are randomly assigned with a role. So you don't know whether you're a speaker or you are an instigator, whether you are the speaker or the detector. But this is how we collect the ground truth. And you can see that once their assignment is there, there is a window that enables the detector to communicate with the deceiver. So this is the base of the signal is what we collected here. All their conversations becomes the base of our computational intelligence. And we collected just this script. We analyzed just that script. We know the agent. We know their conversation because they're logged in MySQL database. And this is an online environment. So we collected the data. And there are more of the screenshots at the end. We also collect their perceptions. And I can tell you that basically people are terrible detectors. They think that they are 100% knowing that the person is deceiving, but the general rate we calculated that is only 52% accurate. So across the board, you know, whether it's co-present or in a virtual environment, people don't detect lie, you know, any better. It's only 52% accuracy. And actually, I found out during this trip that there are a bunch of researchers I admire, I study and cite their work. They also talk about their identifying of many different approach. They sometimes use polygraph system, like in the border control. And there was a research group from Arizona. They used the lie detector actually there to have all the people who coming from Canada into the US, they ask them and collect that kind of information. And their accuracy is about 60%. Okay, so it is better than how people do their detection based on the human sensor's innate ability, right? So I just want to give you these figures and then show you how computationally we can do much better. So then this data is collected. And this is the data collection. And data is also being cleaned. Why do we need to clean the data? It is because some of the players, they misunderstand the instructions. So all their data are being logged in the database. So we have to delete those data out to remove them. So we collected the data across 2 years, 40 participants with 80 different game sessions. And this is the data you see the language that they communicate. They have about 2,100 lines of script. That's the lines of script, and total of 7,000 plus words that we calculated. Those are, where are they coming from? They're basically just based on the chat, in the synchronous environment. And that is very interesting. Basically, human eyes looking at the chat, you don't feel anything different, and how would they tell you anything and give you any intelligence? But we did more. We coded the entire data set with the RIWC coding scheme. This is the coding scheme. We basically, based on the examples of the words, and categorize them into affective process, cognitive process, negation. That means someone saying no, never, these kind of words, pronouns, first person, second person, and there are some social words such as family, friends, humans, and tentative. And we also calculate the time lag. So we incorporated the time lag, the lag between the first sentence and the second sentence of the same player. We also, I think we calculated the sentence of the player and the time space to the next person thinking about what to respond. And that was the time lag. And that was very, very significant in a way that, how much time? Only perhaps seconds. But sometimes the time can tell you that, the amount of time the speaker takes into account to respond a question, especially for sinners. How much time it takes them to respond with an answer. So all these are very meaningful. And they are just how we see the words and syntax as the language action cues. So basically, they were from the previous one. And I encourage you all to take a look at RIWC because it is by the social psychologists that they are also linguistic. They came up with this tool, and I find that's very useful. It's called, it's by the Pennebaker and his co-workers, Dr. Newman, and they work on this. So it's great. So instead of we use a different content analysis, I use the tool to computationally process them. It's a lot more easy to give us ideas of what's going on in this context. So we also calculated the frequency of the words spoken, the wordiness, the relevance of the information provided, and frequency of the words, for example, the sensory words, spatial temporal words, and to see how they work. So this is not the result. This is a byproduct. And I like to say that this result that we got really corresponds with lots of research outcomes 10 years ago. So they already, many people found out that, for example, sinners tend to use affect, sweet words in conversations to persuade, and saints just comparatively stick to the truth. The saints use a lot of words such as no, never, right? And the sinners use engage in cognitive load, heavy cognitive process, and has been using lots of self-reference, first-person reference. So, but there's nothing more interesting in this result except it validates other researchers' work. So we did, by aggregating all these words together, we have a data set. We start to do model. So first we did 3 different models by removing all these different cues and see which models they work. Basically, all 3 models are great. They have very high significance. And so the first model includes all the cues that we can find, we can code. The second models, we remove some of the words that are individually not statistically significant. We remove those, and we further remove time lag because it's not very significant as we remove them, and they all work very good. The F value is 3.1, highly significant. So, and we look at the predictive power, the I square, R square for 3 models, based on the 3 models. They are highly significant, and the adjusted R square is also close to one another. And we further to look at some of the collinearity problems, and we did some diagnostics, and we found out which one should we continue to explore. And the highest eigenvalue we found was the first model. That means even there are some, this is a very big finding we find, even there are some cues, individually they're not so significant, but they together provide the highest eigenvalue. That means they work together in the same model, the best. And the model 2 and model 3s, they don't have the high eigenvalue. So we include all the data together and continue to look at the differences between saints and sinners. And chi-squares of the model is very high, highly significant, with chi-square 35.8. So this is high significance. And we also look at the differentiating with the cut value between the saint and the sinner. So we coded saint as the 0, sinner as 1. So if we cut off value and say all these groups are saint, all these groups are sinners, what is the likelihood that we get, the accuracy high? So here is the result. We get about 75% right on the sinner, on the saints, and 75% right on the sinners. The overall percentage is also, for this model, is also 75%. This is pretty good, right? But we continue to explore. What about we put the cutoff value at 0.6? We said that all these are sinners and all these are the saints. What is the accuracy? We found out that we can predict truth tellers at 85%. That's very, very high. That's great, right? Yeah, exactly. So think about earlier I mentioned that the bunch of information scientists last week, they were talking about the deceptions in many different contexts. They were able to identify 60% accuracy. But here we can do 85% accuracy on the truth teller, the saint. But that is not what we want, because what we really want is the 65% identifying the deceivers. So we say, oh, no, this is worse than the first model, and let's continue to look at the other way around. So we separate these groups and use the cutoff value at 0.4. We said all these groups are sinners and all these groups are saints. And very amazingly, we're able to identify sinners at 82.5%. And that is very high, right? The overall model is 73%. So this is the logistic regressions. And what I want to mention about this is my recent, pretty much in December, being requested or criticized by the reviewer when I was in the process of submitting the manuscript to computers in human behavior. And they liked the study, but they said, your research is too simple, right? You need to do more mixed model ANOVA analysis. And I was thinking, I am not so sure if I can do this. So I did lots of studies and realized that, yes, I collected repeated values, repeated cues per subject. So in a way, the data is truncated into repeated value per subject. And we have 40 different subjects. So they are, in a way, a nested structure. So the cues are nested within the humans for each subject. So based on this data sets, we can analyze the mixed model, multivariate model, and so we identified that this is a medium-sized effect, but the observed power is very high at 98%. And this data, F, is at 2.3 significant. So we continue to look at Mauchly test of severity. And this is important test because it will find out the condition where the variance between all pairs of subject, the saint and sinner, looking at each pair. Sometimes you said, you compare general data, but the individual, each pair, they don't really work. And especially if the data is faked, then it just does not work. Statistically, it just will not show any significance. So between all possible pair of within subject conditions are equal, we found out that the severity is at 0. And that means this condition is not desired, right? In a way that we should look at the correction. So because the significance is 0, we look at the greenhouse gasser correction result and identify that it's significant, and the eta square is 0.129. It is also a medium-sized effect. And the data, the degree of freedom is very high, 102. So this is the within subject effect. And between subject, it is also highly significant. So the F value is 13, and observed power is 95%. This is one last table that you're going to see the results today. We did a post hoc test using Bufferoni correction, and that reveals the differences between saints and sinners are statistically significant. And this is the pairwise comparison. That means you can actually identify saint versus sinner in each pair of the conversation. And you are able to do this. And think about this, the each pair, that means what is that, intelligence community officers such as the CIA or all these people work in their office, the person being tested has to be in co-present room because you have to monitor their pulse and brainwave and this and that, right? And to do the analysis, and the result is like 60, 70%. But if we do this setting, the significance, the accuracy can be very high, and the differences between saint and sinner in each pair is significantly different. So, and this leads us, the research outcome results into the future. So I think this slide is the most wonderful and interesting result. That means there is a hope for the future, and we should do more data collections. So it's just a little implication about this research. It is a very small study. The data sets is small, but the implication is that the language action cues are collectively looked at. It's modeled as repeated value. In a way, the differences between each pair of the participants was statistically significant. You will be able to use a computational tool as we develop this to computationally, based on their simple text, to identify who is the saint and who is the sinner, right? And the implication, and as earlier, the deceiver tend to be less expressive, use more decorative words like sweet words. The deceiver show more negative emotions. They tend to be a little bit more negative and took less time to respond, rather than truth tellers take more time to respond. All these are results. And truth teller took longer time to respond, provide reasoning to their ideas, and use the words of discrepancy such as, yes, we should, we could have done something. So more thoughtful in this way. So these are just looking at individuals' cues. But what is exciting is the collective language action cues as the model. So our conclusion is that it is the overall collective language action cues as stigmergic signals that are salient in spotting out deceiver. So we no longer, I think in the entire research community, especially the intelligence community, they should not just look at single cues and see which one that works better with the other one. And actually, it is the entire model that are salient in differentiating deceptions during the interaction. And note that this is an interaction study, so the interactivity within between the subject is very important. So anyway, to conclude the study, that the study demonstrates potency in computationally identifying the language action cues as the stigmergic signal, and informs the effectiveness and power adapting the computational approach in identifying computer mediated deception. And the future work, as you can tell, can be very simplified into developing an online polygraph systems. And that has a very promising future. And I have another paper that talks about you can use other approach, such as the the machine learning approach, you can increase the percentage of accuracy to 85%. And that is very, very high. So thank you very much for listening to this research talk. Is there any questions?
Question, Dr. Hall. So what was the reception at the conference? Presentation? Did you get any feedback or?
Yes, I did have a couple of questions, and they basically were just asking about what kind of words do deceivers use versus truth tellers. And I think what the humans care about is how you can benefit personally to spot liars, right? But the purpose of this research is not about how I can do it. It becomes a byproduct that the more you study this, the more you identify something for, this is a byproduct, a side effect. But overall, we prove computationally we can build models. The models include all these cues, can spot lies. So yeah, the presentation was wonderful. Kevin Croston was there, Elise was there, and several researchers like Caroline, now she is in Syracuse. Yes. She was there, and several others. And I think other papers were mostly focused on the visualization part of crowdsource. And mine is a very grounded, basic research. But I think it is the data that speaks. I think it was interesting and well received.
Very timely.
Yeah.
Other questions?
Yes,
So
Kessel.
at the very beginning, you were talking about sting metric signals and how that kind of inspired you in this research. So my question is, so for this research, did that come first and inspire your idea, or did you have this idea and then you came across this idea that propelled you to it?
Yeah, the overall theme is of my research is always focused on the identification of computer-mediated deception. So I have this idea, and the language action cues are, part of this. But what I didn't know is the computational feasibility. I know that somehow nobody has ever told me that you can spot liars online. So my initial idea was to see how could I spot liars online, right? There were Dr. Ekman's, they see in the face-to-face context by looking at facial expressions and many different ways. The intelligence community, they use lots of correlations of the heart beeps, the pulse, the temperatures to correlate. And there are many different ways. So I was told that it is impossible. There are so many fake news problems with social media. There is just no way you can spot deception. Otherwise, if it's that easy, then everybody can do it. But for me, it was just a very simple question in my mind. How about I just have a little game and see if I can find something interesting out? I didn't even go with the route of computational intelligence at all until I did all this research outcomes and realized that if I have all this data, how would I do it to increase the accuracy? So, and the most recent discovery was really the modeling of the language action cues in a repeated value in that nested data, and that was huge because finally I think this is that I have never seen these kind of research outcomes in any of the deception research out there, and I know basically who, as you read so many papers, who produce what kind of research in what kind of settings. And this, I would have to say that it is the first discovery that it leads us a future to develop something and being able to identify this computationally. So I think one of the interesting part about research is that you have some general ideas. You don't know where you're going, but you always want to just do it, this way and start exploring. And ever since, I think, in 2013-14, I got this, and then I have been exploring this pairwise interaction, and I think this is just so very interesting. Hopefully I can get more grants and to.
I can't see how you can with this. I mean, this is really exciting work.
Yeah, so I'm glad that it was well received at the conference, and it's also going to be published in 2018 in the CHB journal. And those researchers, they asked me questions. And, at first, I complained to Dr. Hancock. I basically said, why is it becoming very difficult as you work on the research and people challenge you with, extended questions? Sometimes they seems unreasonable. But anyway, it was during the winter break, and I took my time to think about it. And you basically have to set aside your time to study. Is it possible? When you see the challenge, you don't know whether it's possible. Just try it. So I tried it, and I could not believe what I saw. It was not predicted. It was not designed in my research. The nested ANOVA, repeated value. Yeah, that part was not what I expected.
Well, good. That's what you can say to those reviewers.
Right, yeah, so the reviewers, when they challenged me with this question, I wasn't so sure. I provided my manuscript, and they immediately accept everything. So that was fast, because the data speaks.
And you really brought it back to the who cares question and the sort of larger importance of being able to determine at a high degree of accuracy who are the sinners and who are the saints.
Right,
So
yeah.
that's because there is that mixed models and down in the weeds of that, but never losing sight of that larger question that you're pursuing.
Right, yes. If you are interested in looking at how the research is designed, I have all the topic, the scenarios, and everything. I can share with you, and all these random assignments, and we can talk about this in the future.
All right. Well, I think we know where to find her. If we have any questions.
Okay, thank you. Yeah, thank you.